G House? Did they still say G House? I used to go out and watch the tennis. I took tennis here a few times. I used to play on a league actually, and I used to go out and watch the tennis and root for them. I've gone to a few basketball. I haven't gone to anything in a while, to be honest. It's just been crazy. But yeah, I remember being out there saying G House. Yeah. Okay.
Are they any good?
Huh?
Are they any good?
Well, our football team normally does pretty well. Our women's volleyball, pretty much every time I look into it, they seem to be doing okay. I don't know what our softball team is doing, to be honest. Huh?
How's their soccer team?
Our soccer team? And no, do we have a soccer team?
You said what soccer team?
I know the swim team here is pretty decent.
What's up?
They made the state finals last year.
Okay, there you go. There you go.
But Rosemont doesn't have one. It's because they're partnered with Cuyamaca.
There you go.
Has it, but if you go to school at Rosemont, you still can play for the Cuyamaca.
There you go. Yeah.
The swim team here is pretty good.
That's what I thought. I didn't think we had a soccer team. Not official.
Because it used to be just like Cuyamaca, or like Rosemont, I mean.
Oh. I
Or
don't know.
like.
I don't know. Okay. Sorry. I don't want to show off any more of my ignorance about what's happening here at Christmas. Although I could do that forever. Any questions from the homework? Any general questions? Everybody noticed the quiz coming up? Yay! You want more grades, so you desperately want me to give you quizzes. Yes?
Before the next test, can you give a practice test again, like that paper that you did, the take-home one?
I'll think about it. Yeah, I do every one. So for the final, it's going to be a practice final.
And then what about our homework? When did we get that?
Someday. Oh, I got
When he does
some
it. When he does it.
stuff graded.
When he gets the chance.
Listen, guys, so in general, if you give me homework before the review day, I'll get it looked at and give it back to you, so you have it to study. If you give it to me on the review day or the day of the test, you'll get it back someday, because then my attention becomes grade test, and then my attention becomes grade new homework, right? So old homework, I'll tell you this, I think I told you this already. My priority with old homework is grading the people who made lower grades on the test first, because they need more help from me. So it does happen where I sometimes give you, like a week before the final, I'll give you homework that I haven't looked at.
That's why.
Because you did well on the test, you didn't need as much help from me, right? I am one human.
Surprised they don't give you
With
like
205 students, huh?
Surprised they don't give you like a teacher's assistant.
Well, we have to hit a certain level of students in the class,
Oh.
and because this class is capped at 30 in the first place, I can never get to the 45 that I would need anyway, so. Okay, so,
You be a TA.
huh? Oh,
I'm talking to him.
gotcha. I thought you said me, I'm like, I'm my own TA. Normally my joke is, yeah, my TA, I'll talk to him, hey you, yeah, what's up? Georgia,
Oh, not Georgia.
you're not Georgia. Marlena,
I was gonna ask
Alex, Lincoln, Brittany,
You said bad homework. It's pretty good.
that's correct.
What do you do?
Jalen.
Oh. Did you turn in 1.2B?
Ethan?
Oh,
Yeah, that's what I was asking.
Ethan?
Which normally you're supposed to turn in. Yeah.
So for example, I just turned back some section 1-2 homework, because that's the new homework, yeah.
so this is just a solution to like the whole homework thing. How come, and some people might not like this, why don't we just like do corrections in class? And then so you have kind of like an idea of grade. You know what I mean?
No, how do you mean do corrections in class?
Like instead of you having to do it all by yourself, well, you can switch it up and pass them back to us and we can help you grade them. That way you can just submit them.
Oh,
Because I couldn't take a lot of classes.
that's one way. Now listen, guys, so I am single with no children. If I was married with kids,
Yeah, I thought about that.
if I was married with kids, I would almost definitely every class would be online homework. Because as it is, I don't have any time. But I hate online homework because I feel like I need to put eyes on work. Because it communicates to me if there's something everybody's missing, I'm like, okay, I need to review that. If there's something some people are missing really bad, I'm like, okay, I need to talk to them. You guys see what I'm saying? I need to look at work. So I'm not a big fan of online homework. I'm teaching Math 285 right now, I make it optional for them because they should be a little more self-sufficient at that level, right? Is what I would hope. And sometimes it's proven wrong, but we'll see. I don't know. So that's just something crazy I do. Yeah.
I think, I know we do a lot of lecture. Sometimes when I look at a question in the book, it looks completely foreign than what it looks like in the classroom.
Totally. And that's why it uses the concepts we discuss in different ways.
Right.
So it's sort of like if I gave a test that tested on every single little concept, it would be this big.
Right.
So if I gave a lecture that went over every possible incarnation of a concept, it would take years.
Your tests are easier to read than the homework. Like I'll have a harder time doing
Yeah,
the
yeah, yeah.
homework.
And it's kind of like, anybody ever play basketball?
Yeah.
You know that they make, I think I've said this before, tell me if I've said this before, they make slightly larger basketballs that you can practice with. It'll still fit through the hoop, but if you practice with a slightly larger ball, same mass, same weight, same everything else, just slightly bigger diameter, and if you can get that sucker in the hoop, when you start playing with the actual normal size ball, it's so much easier. So I like to think of homework as being that pushing you, and then a test is a little more nuts and bolts. I still will have some problems. Now, real quick, how many tests have we taken? One. And it had an entire section missing from it than normal for me. So it was smaller than it normally would have been. So enjoy test 1, I think is what I'm trying to say. Test 2 is going to have a bigger conceptual load, right? I do like to give more questions about, you see this student doing this, how would you explain it? And if I ever give you a question on the test like, how would you explain this to a student? I need you to pretend like you're talking to the student. And so if you say, well, I just say it's wrong and it should be this, and no, is that what you would say? Shit. So I need you to tell me, how would you sort of develop the idea for the student? So I'm kind of testing you on 2 things. Do you understand the idea yourself? And do you understand how you explain it, right? Which are obviously 2 things that a teacher needs. You need to know how the hell to do it. You need to know how the hell to explain how to do it, right? Okay.
We're gonna get through this
We will.
with our heads.
So one reason I have the beginning of every class is homework questions is because of exactly what you just said. There are several homework questions that are weird. So if I don't hear certain questions, I'm worried that nobody's doing the homework because I'm like, I should hear a question about this one and this one because they're weird. I expect to hear questions. So if I don't get any questions about it, I'm like, well, shit, nobody's doing the homework. That's their choice. Okay. Yeah.
Not necessarily a homework question, but more of a test question. When you corrected the tests and stuff and like you up the grade, like, cause we did the corrections, would you write on the back, we got them wrong?
Sorry?
Like, for the correction?
On the corrections, I'll mark through if it's wrong.
Okay,
Yeah.
I'm just, okay.
Yeah.
So it was like, I just got like the upgrade and I was like.
So if I didn't mark through anything, you should have gotten the full points.
Okay.
As many points as you could have. And
I just
remember,
wanted to make sure I did them all.
Okay,
right.
okay.
Thank you.
yes.
Okay, so I have a question about one of the homeworks. But
Sure.
Is it okay if it's 1.2?
Yeah.
Okay, because I don't want to go back, you know,
1-2 is still
part of this.
part of what we're talking about. Yeah. Which one?
Number 20.
Oh, is that the one? Is that set B?
Yeah, step B.
Yeah. Yeah, that's the one, Ramona, that's the one we were talking about. Let's see. We need to do this. There we go. So this has got a bunch of matches, is this going? Yeah. So this one here. Why aren't you up there? Rawr. There we go. Find the total, if the pattern illustrated next is continued. Find the total number of 1x1 squares in the 30th figure. Okay, so just like with the 33 to the third or whatever, remember that problem, you had to kind of like do a few examples to get the pattern. How many squares are here? 1, here, 4, And then what is the pattern? What do they keep doing?
They're adding, so it's like 1, 3, and 5, and then.
Yeah, they're adding 3 and then they're adding 5. Can somebody tell me?
That's adding 5 to.
They keep adding the next odd number, correct? Okay. So what comes out of this is really intriguing. Can you guys tell what kind of number these are? 1, 4, 9.
Oh, squares.
Yeah. The next number I would add would be what? I just added 5. What's the next odd number? 7. What's 9 plus 7? 9 plus 7?
14.
9 plus 7? 16. Oh. And is 16 a square? Yeah. You see what I'm saying? This is a really neat thing to know. And I'll come back to the problem in a minute. All squares are separated by odd numbers. And they actually are a perfect sequence of odd numbers between them. That actually leads to a shortcut to do a square of a, like, anyway, okay. I'm not trying to remember exactly how that goes. Just that's a cool thing to know. Squares are separated by a sequence of odd numbers, which is just kind of neat. Okay. So this says the 30th figure. So the first figure has 1 square, the second figure has 2 squared. So the 30th figure will have,
Oh, so
30th figure will have, 30th, right? We'll have how many?
I thought I said 13.
Okay, that's what happened, yeah.
That does look like a 13.
Understood.
That's
30th, yeah.
30,
Yeah. You don't see the word 30th too much.
I don't like that. That's in my brain.
I like it.
900.
English is weird.
So it'd be 900.
900, yeah. Now, what did we just develop a pattern for, specifically?
So like each.
No. The numbers are squares. What do they represent? What does 4 represent in the second figure? How many blocks? How many little squares, correct? So that will not help me with part B, correct? I haven't looked at the perimeter at all. Can somebody tell me what the perimeter of the first figure is? 4, right? If I'm teaching a matchstick as a unit, then it's 4 matchsticks, right? I don't know why I said matchsticks. Did I say anything about match? Toothpicks, okay. Look at me, I just want to set the world on fire. Okay. What is the perimeter of the second figure? Don't say anything, just think about it. The perimeter of the second figure. Okay, who's got it? Okay, so you got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So the trick is you don't count the interior ones, because if I'm going to walk the perimeter of the building, I'm not going to go into the building. So I'm not going to go in. I'm going to go around, right? So now I'm trying to develop. So now I need a new pattern. I need a pattern that talks about the perimeter. You guys kind of with me? Now, one thing you can notice. Let me help you out a little bit. Does that help out any yet so far? One other thing. See how this eliminates 3 of them?
Yeah.
So it's not just, it's not, and also, do you see how some are how do I want to say this? So if you just look at, it's not 4 times 4, because doesn't each one have 4?
Yeah.
But you can't do 4 times 4 for a couple reasons. They share some, plus you don't even count these. You guys with me? So there are 3 of these that I wouldn't count, which actually relates to 1, 2, 3, 4, 5, 6 sides. Let me see if you guys are with me. Isn't this side in 2 squares?
Yes.
Okay. 1, 2, 3, 4, 5, 6. What's 4 times 4 minus 6? 10. 10. Isn't that what we just got?
Yeah.
So it's about how many internal ones are you not counting? That's another way to kind of look at this. And again, this is a good problem for if you can't get the answer, show me what work you're trying to do. The answer is icing on the cake here.
I took it, like, I guess drew them out.
Yeah.
And try to find a pattern within.
Of course, yeah, that's what I'm saying. So you might have to draw the next one. You might need another example to continue the pattern. So for example, what's the perimeter here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16. Right? Did I get everybody? I think so. 16. So I got 1, 10, 16. If you do one more, you might be able to just directly see the pattern. You guys kind of see what I'm saying? But the thing you have to realize was part B requires a brand new pattern. Part A was just the pattern of counting how many squares. Part B is about perimeter. I haven't looked at that at all. Shit, I gotta kind of reset. I gotta look at perimeter now. You guys okay with that? No, okay. Some of you guys are like, I'm not gonna tell you. So again, I know chapter 1 problems can be frustrating if you can't quite get the answer. That's why I ask if you have questions, that's why I have office hours. But also, the most important thing for this is just show me what you're trying to do. That is the most important thing. Getting the actual answer, I need it, but it's nowhere near as important as what is the process you're trying to use. That's what's more important. And that's weird. But when you're learning stuff, it's the process that's important. If you understand the process, you can work on any little brain farts or whatever the hell is keeping you from getting the right answer. If you don't understand the process, that's huge. That's a big problem. Yeah.
So for the 4 times 4 minus 6, I know we got the minus 6 rounds. But what
Oh,
about the 4
yeah.
times 4? Is that
Oh,
4 sides?
each block has 4 toothpicks. So if I just blindly thought, okay, I've got 4 blocks, so 4 times 4 is 16, why isn't the perimeter 16? For 2 reasons. I don't count these sides, and these sides are in 2 blocks. Yeah. Now, I'm not saying you're going to have to use that fact, but maybe you will. Draw one more picture, I would say. Right? It's not hard to draw one more picture because you just have to draw how many blocks down here. You already told me. It was 1, 3, 5, 7, right? So another way you could look at this is, when I add these 3, how many sides did I actually just add? 1, 2, 3, 4, 5, 6, 7, but I also took this one away, right? I don't know if you guys are with me. So I had 4 here, correct? I'm trying to show you a different way to look at this. I had 4 sides here, correct? Perimeter is 4. When I added these 3 blocks, did I add 1, 2, 3, 4, 5, 6, 7? But 7 plus 4 is 11, right? But did I then subtract this one? Am I including this one for the perimeter? Nope. Do you guys see what I'm saying? So that's a physical realization you can make, and then you can see, does that help me? Does that help me get to the next thing? So there are multiple things you can notice about this. So, I need you to understand, I can't tell you, here's how you do this problem. That's not the point. Because this problem, how big does this problem matter in the universe? This problem is nothing. What's important is, do you know what to try? That's what's important. Do you know what to try? Do you know what to try to do? Do you know what to try? That's what's important. That's why the work is the most important. Answer doesn't matter, because who cares? Who's over there going, we need to know the answer, or else we're all going to blow up? Not a damn person in the world's like, toothpicks, shit, get up, ah. What's important is, what do you try? What do you try? Do you understand what the question wants from you? What do you try to do to answer the question? Right? If you don't get the answer and you showed me some reasonable work, that's going to get most of the credit. That's what I want to see. But this problem, I'm not going to say, if you see a problem, a toothpick problem, here's what you know. No, I want to see what you try to do with this. Yeah.
I guess my dumbass would just literally draw it out to 13%.
Oh, well, the first question is the 30th, so I hope you give up pretty quickly.
Okay.
Yeah. Right? I understand about the 13th, but the 30th, you're like, no.
I guess I would do it to the 10th time and probably just times it by 3.
You might have to do, I would say, one more,
I just don't know.
maybe 2 to continue. Do you all see that we got part of the pattern already? 1, 10, 16.
How many would you say is?
I'm sorry, 4, 10, 16. Thank you. I have a 1 there for some reason. 4, 10, 16. Right? Real quick. 4 plus 6 is 10. 10 plus 6 is. Okay, now, if you do one more picture, you can see if that is the pattern. Do you see what I'm saying? Maybe that's the pattern. Maybe not. If you draw one more picture, not 30. Yeah?
If you draw one more picture, it'd be
25.
That's for the squares for the other
Yeah,
part.
you're right.
So it's 22. And then 16 plus 6 is 22. Isn't that crazy? So now you gotta figure out, if you feel pretty good about the pattern being every time I add 6, here's the way you could do it. If I start at 4, how many 6s do I add to get to the next one? 1. How many 6s do I have to add to get to the third one? 1 more, so that's 2. Are you guys with me? What's 4 plus 6 times 2? It's 16, correct? So they want to know the 25th figure. Let's see if you guys are cool with this. To get to the third figure, I had to add 2 6s. To get to the 25th figure, I have to add how many 6s? 24. Yeah. I just did the damn problem for you, damn it. Alright. Sometimes I can't stop myself because it's kind of cool. So again, yeah. But I need you to go through it a bit yourself. But do you understand what just happened? This is the whole reason I say, I don't mean specifically with the problem, but that's part of it. Just ask questions at the beginning of class. That's why I have time for it. Okay. Yeah. Which one?
So like number 3, like I just don't think I understand what it's asking. What is
3 in part A?
in 3.1 part A, yeah.
Okay. Cool. Oh shit, let me see. Alright. Which of the following sets are closed under addition? What does it mean for a set to be closed under addition? What does it mean? If I take 2 elements of the set and I do an operation, add them, the result needs to be where? In the set. Does that make sense? We call it closed. Math people, we have trouble with words. We do. Words no good so much. But sometimes it makes sense. Closed to me makes sense. I don't have to go outside, then I have to open the door to go get the answer. If I don't have to open the door, it's closed. It's in there with me. It's in the house. So, can you imagine any 2 numbers from the set, you add them and you don't get another number from the set? If you can, tell me. Like what's 10 plus 20? 30. It's in there. What's 30 plus 20? 50. If I follow it, is that in there? If I follow the pattern, is 50 in there? Yes. Can you see these are all multiples of 10? If you add a multiple of 10 to another multiple of 10, don't you get another multiple of 10? So is that closed under addition? Because I'm never going to add 2 parts of this and get something that's not in there.
Not in the multiple.
Not in that set.
Do we have to have the dot dot?
That's
Without the dot dot dot, it would not be closed. I really want this. If I didn't put the dot dot dot, that's the set, correct? What's 20 plus 30? 50. Is it in that set? It would not be closed. With the dot dot dot, I get every damn thing.
Infinitely, that's
Yeah.
within 10.
What's 20 plus 30? 50. What's 50 plus 80? 130. Well, that's down. That's in there if I go far enough, correct? You with me? What's 130 plus 3,000? 3,130. It's in there if I go far enough. I'm going to find it, right? Do you guys see? So it's related to this. If I have 0, 1, is that closed under addition? Because 1 plus 1 is 2. If I add 2, is that cool now? No. I have to add every number, every counting number after that, correct?
Wait, if you would have closed it, that would have been, what would have happened? Like, what is that?
If I would have stopped at 2, what's
Right.
1 plus 2?
3.
Is it in there?
No.
Not closed.
Got it.
Shit, so if I put 3, the minute I put 3, now I get 2 plus 3, and I get 1 plus, oh shit. So I have to keep going forever. You guys with me? There was another problem like this earlier. Do you guys see the point of this problem though is, they're just, do you have to be able to tell that they're multiples of 10? No, you just have to say, can I imagine any 2 numbers and I add them and I don't get, so like part C, I just gave the answer away. Part D, I just gave the answer, look at me, just doing your homework, damn it.
So if you add them up and it does equal something in there, then it is closed.
If you cannot add 2 elements and get something that's not in
Yeah.
the set,
Then
then
it's
it's closed.
closed.
Yeah.
What about the 0?
0 plus 0 is 0.
And 0 plus 10
Okay, so
is,
it's
0 plus 10 is 10, that's in there. 0 plus 20 is, it's in there. Do you see what
Wait,
I'm
how
saying?
is it in there if it doesn't have an ellipsis?
What do you mean? No, I'm sorry, going back to this.
Oh, sorry.
Yeah.
Okay, so close.
This one is no good. Even though 0 plus 1 is 1, 0 plus 2 is 2, 1 plus 1 is 2. Unfortunately, 1 plus 2 is 3. Shit. So it's not closed because I have to go out, I have to open the door and go outside the house to get 3.
So then D, 1 plus 2 is 3, so that's not close because you got.
Not close. What about B?
3.
Might as well finish the damn thing. What
Yeah.
about B?
B is
Yeah.
not.
Take any element in the set and add it
So it is
to another element in the set. 0 plus 0 is the only thing. What's that?
close.
Yeah, it's 0, so it's close.
Not a-
Yeah, yes.
Stupid question. Stupid question. So earlier your example was like if you put 0 and 1, and then you said 1 plus 1 is 2.
Yeah.
But then you said, you add one element in a set with another element in a set. Would that?
But they don't have to be distinct. It could be the same number. So I can pick one of them. Sort of like if I had 0 and 1 in the hat, and I picked a number and then I dropped it back in and then I picked a number, couldn't I get 1 and 1? Okay, that's the idea. I could use the same number again. Yeah.
Okay.
So if I said pick 0, 1, you could say 1. And then I say pick 0, 1, you could say 1 again. Okay.
So 3.2 set A, problem 18, it'll probably be a couple seconds. It's the square dancing contest has 213 teams.
Number which one, sorry?
18. Right there, the square dancing one. You get a decimal, how should we handle the decimal? Should we just
A
round out?
square dancing contest has 213 teams of 4 pairs each. How many dancers are participating in the contest? Is this a division problem? No. Each team has how many people? 4. No. 8.
Oh.
4 pairs, right? If you have 4 pairs of socks, you don't have 4 socks. You got 8 socks, right?
Go the other way though.
What's up?
What if you have 4 pairs of underwear? You only have 4.
True. I mean, the other articles of clothing are weird with the pairs. These are a pair of pants, even though
Well, they have 2 legs.
2 legs. So I guess this is a pant and this is a pant. Is that the idea?
Okay, but a pair of scissors.
So I got a pair of pants.
It is a pant leg.
All right. I'm sorry.
Right now he's right.
Oh my goodness.
He's close.
All right. I love it, guys. Okay. This is awesome. Tangents are awesome. Is that okay? Is that one okay? So that one is totally multiplication, right? So each team has 8 people.
Yeah, just
there are 213 together.
To figure out how many times 8 goes into.
No, it's not division.
No, bro.
There's
There's 4
240
pairs, so there's 8 people.
Yeah, 213 teams of 4 pairs each. So each team has 4 pairs of people.
Oh.
Yeah, good. Okay.
Okay, so yeah, just dyslexic.
Yeah.
Okay.
You're good. The book, again, math people, words, sometimes no good. So yeah, some of these problems are definitely worded a little freaky, which is another reason why I want you to ask questions. You guys,
Why wouldn't we divide 213 by 4 then? They just have 4 pairs and then figure out how many is in each.
Because that's not what the question is.
if I had 20 boxes, and each box had 4 pairs of apples, right? So 1 pair of apples is 2 apples, right? So I had 20 boxes, each box has 4 pairs of apples. So 1 box has how many apples? 4 pairs, right? I know it's weird with pairs. 8 pairs in a box, and there's 20 boxes. 20 times 8, right? To figure out how many total apples they have. This is all this is. 213 teams. Each team has 4 pairs of people. Right? Each team has how many people? 8 people. 4 pairs, 8 people. And there's 250 teams. This is completely multiplication. Now, I agree with you. It's not worded the best. I agree with you. Okay, now I will say this. Even though some problems are worded incorrect, kind of weird, you should still read the book, right? You should still read the examples at the very least. I like to tell my students who are getting in higher level math classes, at some point you're going to get a book. It's got concept, problems, no examples. So I'm like, appreciate the hell out of the fact that you have examples you can go to. You know, so at least look at the examples, but try to read too. We can construct sentences sometimes, so you might as well try to see what we do. Anything else from the homework while we're doing this? Yes?
The different properties in 3.1, is it the associative property, the whole number addition, the identity property, are those the different properties?
Yes. You got commutative, associative, identity.
Okay.
When we get to multiplication, we got distributive. Right? Is that cool? Alright, so let's get into some new stuff. This is the new stuff.
I
You got it?
Thinking that same thing.
Oh, the song? Oh, yeah. I eternally have some kind of song going on in my head. Now it's dancing. Alright. This is the new stuff. Given any, let me see where am I at? Here we go, okay. So I will say, one thing I left out of the discussion last time that was on that sheet we did was the transitive property. Yes. So that probably freaked you out. I appreciate that at least one person Googled it, which is great. You all have access to the internets. So let me first start off with the idea of ordering. This is actually this is 3-3. We got a couple things to finish up. I haven't officially talked about exponents. I kind of threw them at you. We did talk a little bit about zero, power, and so forth. Can anyone tell me if 3 is less? Let me see. Why is 3 less than 5?
Wait. Ordering who let what?
Because,
Ordering whole numbers.
Oh, hold on.
Yeah. Say it.
because 3 is just small.
By how much exactly?
2.
I love it. It's exactly the way to look at this. So you could have answered it in several different ways. We've actually looked at this before. 3 comes before 5 on the number line, right? 1, 2, 3, 4, 5. So 3 comes before 5. In the chant, 3 comes first, right? So several ways. But officially, the technical reason is because there exists a number in this case 2, such that 3 plus 2 equals 5. Since I have to add something to 3 to make it the same as 5, 3 is less than 5. This is related to the comparison approach. So compare 3 to 5, it's too short, right? You guys kind of with me? Too short meaning it's short by 2. You guys all with me? So in general, if I tell you that A is less than B, and A and B are whole numbers, can anyone tell me what that technically means?
Wait.
There must be a number.
There is a number
Good.
between A and B where if added to B will be B.
There exists a number n such that A plus n equals B. Does that make sense? I mean, that's not the immediate way you would consider less than, but if you think about it, yeah, if the number's smaller, I have to add something to it to make it the bigger number. That's all it's saying, right? You guys with me? Now, transitive property of inequality. The transitive property itself is if I'm the same age as you and you're the same age as her, then I'm the same age as her, correct? Right? You guys kind of with me? Transitive property, I sometimes call it the duh property. If A equals B and B equals C, then A equals C. Duh. They're all equal. Ooh, it's amazing. Transitive property for inequality says this. So given A, B, and C are whole numbers, if A is less than B and B is less than C, then A is less than C.
A is
So if you're younger than her and she's younger than me, then you're younger than me. Does that follow? You see what I'm saying?
That's actually
Okay. Real quick, just to show you, if I wanted to prove this using that idea, let's see if you guys can help me with this. Using that idea, what can I immediately write from this guy? Do you see how if this and that? So I know this is true, and I know this is true, and I'm trying to show that that means this is true. Does that make sense? If I know those two things, then this must be true. If I know this, what can I write? If A is less than B, what must be true? There must be some n such that
yeah, that n is equal.
A plus n equals B. If this is true, I'll write that more in English. If this is true, what does that mean? Now let's say B plus. Can't use n again because it might not be the same. N. We stop for a minute. You guys see why I can't use n again? Because it doesn't necessarily have to be the same amount.
Wait, it can't be the same amount.
No, it could be. Of course it could. This could be 2 and 10. This could be 10 and 18. They both are 8.
Oh, okay.
Yeah, okay. It just doesn't have to be. I really want you guys to. If this is 2 and 10, you all agree with me. That's 8. But this could be 11 and this could be 10 and 12. In which case that's 2, not the same number. Okay. That's why I have to use a different letter, just because the same letter means somehow you know it's the same. Now what is, so watch this. B is A plus N, correct? Can't I replace that? This would be A plus N plus M equals C. Is C equal to A plus something?
Yeah.
Yes, so therefore this is true. Right, what would this mean? A plus something equals C. Isn't that what we just wrote down? A plus something equals C? Is that what we
Can
just
you
wrote?
go over that again, like the whole before?
Real quick, you're cool with this?
Yes.
And you're cool with this? Same exact idea, just written for this guy, right? If B is less than C, then B needs something to add to him to be the same as C. Okay. What is B? What does this say B is? Good, so wherever I see B, I can replace it with A plus N. Yeah, like it. Sneaky algebra. Remarkably enough, that's called the, I'm sorry, go ahead. That's called the substitution method. So if I know that B is A plus N and it's sitting somewhere else, I can just replace it with freaking A plus N, because that's what it is. Now, I understand all of us are saying, we don't know what the hell B is.
Well, we do.
B7, no, but I do know B is A plus N. I know it, so I can write that there. Okay, how much do you have to understand this? Not a ton, but I kind of want you to follow. This is the proof of this. Okay. So if I ask you a question like, illustrate why 7 is less than 11, using the definition of inequality, you could do it. You could find the value of n.
Wait, this is called definition of inequality?
Let me see what the exact wording is for that sucker. Oh shoot, I'm in the wrong place. Oh, yeah, it's called, they don't give it a name. It's just called the less than for whole numbers. I love it.
So original.
Yes. Okay. Now, real quick stuff about we talked about exponents already. I just want to kind of make sure everybody's got every property down. Why did we invent exponents? Us silly freaking math people. Because somewhere in the world, there was somebody
Who was lazy.
who had to write, no, poor little guy was old. He had to write x times x times x times x, and he had to do it like 30 times in this paper. And he's like, screw this shit. And then he said, let me make this 5x, and then he said, oh man, this other guy said that's x plus x plus x. Damn it. He beat me to it. So this could have been true. Everybody with me, that's not true. You guys with me, that is not true, what I've written. But maybe he said, oh, I want that, but somebody already took that to mean x plus x plus x plus x. Are you with me? So then he said, all right, so I'm gonna shove the 5 somewhere else. If that looks like division, that looks like a weird hat, I don't freaking know, let me just put it there. Now listen, that's not very far from the truth. It's a bit of a drunk history, man, but we just had to choose. I wanted to tell somebody I got 5 x's multiplied. This already meant 5 x's added, so we just had to shove the 5 somewhere. We could have made the symbol this, 5 with an x. That could have meant x to the 5th power. Totally could have meant that. Kind of happy we didn't do that. Right? You guys with me? So one level I want you to understand, and this doesn't necessarily help you teach some little dude what 3 plus 2 is, but you need to understand every damn thing we work with was a decision that had to be made. Every symbol, every notation we use is a decision we made. And then the rest of us, including the little people you're going to be teaching, have to catch up with those decisions. Right? I think we've kind of talked about this before. Every symbol we use didn't have to be the way it is. It was a decision. Are you guys with me so far? So, just to save time, or because they're lazy, I agree, we decided to write this. So thank God, if I have x times x 80 times, I can just write x to the 80th. I don't have to write x. Yes. Now all the properties come from this definition. So what is x to the 5th times x squared?
X to the 7th.
Yeah, because I have a chain of 5 x's, and I'm going to tack on 2 more x's. So of course I end up with 7 freaking x's, right? That's a lot of x's, Jeff. Okay.
This is to write down.
Hmm?
Should we write this down?
That's up to you. Yeah, you can take notes or not. So what is x to the 5th divided by x squared?
X to the 3rd, x cubed.
Yeah, so top is x, 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 and the bottom is x, x. How many x's cancel? 2. So how many left? 3. So never do this shit, right? The shortcut is I'm gonna lose this many x's, right? So that's why it becomes subtraction. You guys all with me? Yes.
And you can't like add like you can't do like x to the power of 5 plus x to the power of 2, right?
Beautiful. All right. So a little side note. Kick ass.
Because they're 2 different things.
Yeah. Oh shit. My little camera's facing the total wrong direction. It's not your fault, little camera. Yeah, so, well, let me do one thing before I do that. Well, okay, here it is. I can do this all day, correct?
Yes.
Okay, 2 things. Can I do this, like you just said? I can only add like terms. So if this was this, can I do this?
Yeah.
How many x to the 5ths are there?
2.
2. So if a student wrote this,
No.
what would you say to them? I kind of give the game. This could be a question on the test. Huh?
Close but not quite.
Close but not quite.
Hit him with the stick.
I'll tell you what I say when, how big? No, sorry. No stick. What I would say to a student back in the day when it was legal for me to teach this is I would tell them, I don't see any x to the 10ths. Right? How did you get 1? I don't see any. I see 2x to the 5ths. Right? So I try to get them to understand the coefficient is collecting so many whatevers. Right? The only time an exponent can change is when I do something related to the operation this represents. What does exponent represent? What operation do exponents represent? Multiplication. So that leads me to the kind of the next thing is, what is this? That's x to the 10th, right? Now real quick, don't they have 2 groups of 5 x's? So if I wrote this out, and of course what do I do with the powers when I have like bases? What do I do with the powers? When I have like bases, I add them. So I get 10. So what's the shortcut? We don't do this shit. We just go, that's exactly the definition of multiplication. What's the most basic definition of multiplication? I have 2 groups of 5 things. I have 10 things. That is the most basic idea of multiplication. You guys kind of with me? Maybe? You can see how a student will look at this and make it 7. You can see why a student will look at this and make it 10. Well, what I try, when a student tells me the answer to this is 10, I tell them something very strange. Let me see if you guys are cool with this. I never have to say this to anybody, but let me see. I tell them there is no 5 anywhere in this whole equation. There's no 5. There's no 2 in this whole equation. There's no 2. And then they go,
You're drunk.
did you miss your meds this morning? Because I mean, but what is that? That's not a 5. What does that mean? That's not a 5.
That means times much.
That means,
There's
no,
five
what does it mean?
X.
There's 5 x's.
Oh,
So there's x, 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 and then there's x, x, sorry. And you don't get 10 from there, right? So I'm trying to get them to realize there's no reason you would do 5 times 2, because there's no 5, there's no 2. You would do 5 x's times another couple, that's 7 x's, right? You're just counting x's. So you're not multiplying 5 and 2, you're making more links on the chain. This is the chain of 5, add on 2 more links, now you got 7 links, 7 chain. Okay. Maybe? Okay. Man, you guys look beat down, I'm sorry.
but even though that's still a multiplication problem, though, right?
Totally, yeah. But there's no 5 times 2. Anyway, there's what the problem really is, correct?
There's only x times
This
x.
is 5 x to the 5th times x squared. That's what it really is. These aren't 5 and 2, they are shortcuts, so I don't have to write them 5 times. Does it make sense? Alright, you can think I'm crazy, that's fine. So let's see. Then we got the one we talked about the other day. What's x to the 0? So what would I put, if I had a square down here, what would I put up top so that I can use this property and have a 0 at the end? What would I subtract from 2 from to get 0? What minus 2 is 0? 2, okay. So from this property, isn't that x to the 0? What do? Don't you subtract powers? And what you get 0. Cool. Right? What's happening? Are you guys okay?
I'm a little lost on this one, not gonna lie.
Alright.
Yeah, flat out now.
Alright. Let's do a few of these. What's x to the 7th divided by x to the 4th?
X cubed.
What's x to the 11th divided by x to the 8th?
X to the
X, huh? X
Sorry.
cubed. That's right. What's x to the 417 divided by x to the 416? X. Because what do you do with the powers? You subtract them. That's how you get the power that's on this, and we normally don't write 1 because we want to save some time somewhere. So what is x squared divided by x squared using what we just did? X to the
0.
0.
Why wouldn't we just write 0?
Because it's not what it
Because
is.
there's still an X.
It's not what it is. Everybody stay with me, stay with me, stay with me.
One.
Stay with me. Every damn time, what did we do with the powers? Subtracted. So why would this be any different? 2 minus 2 is 0, right? What is something divided by itself? 1. This is what you guys are trying to yell at me, and I didn't want that yet.
Sorry.
So what is anything to the 0 power?
1.
1. Here's another way to look at this. Guys, help me out. If I start with x squared, yay. If I take x squared divided by x, how many x's do I have left? Let me write it like this. X squared divided by x. Don't even, what's happening? What's up? You guys all right? If I divide x squared, I had 2 x's, I divide 1, how many do I have left? 1. Right? If I divide that by x, how many x's do I have left? So this is x squared, the power went down by 1. I have no x's left, correct?
Yeah.
No x's left. Are you guys cool with the fact that in front of anything there's an understood 1? Is that cool?
Yeah.
Okay, so could I just throw this in there? You guys with me? Okay. This literally means there are no x's. So all you have then is the understood 1. So if I start with 1 and I multiply an x, now I can just write x. I don't write the 1 anymore. Go backwards. If I divide that x away, I'm back to the 1. I have no x's. Literally have no x's. So it must be just the 1 left. That's another way to look at this. Here's another way. You ready? There's one more way. What's the only number I can multiply by and something stays the same? What? What would I multiply 7 by so it doesn't change? It stays 7. I multiply 1. Is there any other number that can do that? Hell no. You with me? So if I multiply something by something and the first guy stays the same, that second dude must be 1. Do you guys agree? Because that's the only damn number that can happen. You with me? Alright, some of you guys look like you want to hurt me. It's okay. If I do x to the 6 times x to the 0, what do I do with the powers?
You add them.
Add them. What's 6 plus 0?
6.
Did this thing change? What must this be? 1, okay. Because the only number I can multiply by and keep something the same is 1. And sure enough, when I multiply by x to the 0, shit don't change. So it must be 1. So there's 3 proofs of why anything to the 0 power is 1. Yeah. Almost anything. Yeah.
Okay, I was gonna say in that, it would always be 1 and it's only because it's to the power. Like, obviously, 0 times.
X times 0 is 0 all frickin' day,
Right,
even
but-
Tuesday.
Since it's a power, since that understood 1 is there, that's why there's always 1.
Since it's a power, it's completely different considerations for, yeah, okay. So if I said, how many x's are in this? 2. You guys agree?
Yeah.
You guys agree?
Yeah.
So there's 2 of them, there's 2 of them. How many x's are in this? 1, there's 1 x in there, right? How many x's are in this?
0.
0 x's are in that, right?
Wait.
I know, so it'd be times 1, that's the x to the 0.
Oh.
There's no x's in there. So x to the 0 is 1. Okay, let me go back. Okay. Okay. Yes.
Stupider question.
No.
You know, you said like there's only 2 x's, blah blah blah. But wouldn't like the idea of 6x be like x plus x?
Oh, totally, I'm with you. But what I mean is like as a factor, that's my
Okay.
fault. So there's 1 6 and there's 1 x. Here there's 7 times x, right? So there's 1 7 and 2 x's, right? Okay. Okay, okay.
Bring x to the 0 to ignore it.
Do it again?
It's just 1.
Yeah, not ignore it, it's 1. Yeah.
Well, like if we're multiplying it, like.
So like if I had 6 plus x to the 0, I can't just write 6, you know what I mean? It would be 6 plus 1, yeah. So I want to be careful, don't ignore it, it is 1.
You think that just go 1?
You with me?
Yeah, I didn't even think about it.
Yeah. So if I said, now listen, guys, help me out. Can everybody write a 1?
Yes.
Next to that, write no x's. Wouldn't that just be the 1? You're like, hey, I'm done. Write a 1. Now don't write any x's. That's 1. That's exactly what this means. No x's means you just add the 1.
Cool.
Okay. I like it. If x to the 0 was 0, then x to the 0 times x squared would be 0. Is that true? No, it's x squared, right? 0 plus 2? So x to the 0 can't be 0. Okay. Alright, and just to make a complete picture, I know negatives don't exist for us yet. But what would x, alright, let's see what the action. What is x to the negative 1?
That'd be 5.
Let's explore it the same way we did with the 0. If I had an x squared on the bottom, let's make it x cubed, yeah. What number, what power would I put up here so it'd end up with a negative 1? 2, beautiful, because 2 minus 3 is negative 1. Are you with me? What do you do when you divide like bases? You subtract the powers. That would have to be a 2. Is everybody with me? Now, help me out. Write it in expanded form. What's x squared expanded?
XX,
And what's x cubed?
XXX,
How many x's cancel?
2.
How many are left?
1.
Where?
Hold on.
Where? On the bottom, yes? Isn't it on the bottom?
So it
Yes.
means 1 over x.
So negative power means flip. So real quick, what is x to the 5th divided by x?
I'll write my 5x's.
That'd be
Don't even, don't do that, don't do that. we know how to do it. What's the power understood to be here?
One, maybe X
One,
squared.
okay. So what's, yeah,
X.
I had 5 x's, I canceled 1, so I got 4 left. So the shortcut now is subtract, right? Because we're gonna lose some x's, we're gonna lose 1 x. What is x to the 5th times x to the negative 1? What do you do when you have like bases? You multiply.
5 times -1.
No, come on, no.
It'd be
Add.
You add the powers, right? What's 5 plus -1? 4. Same answer, yes? So this acts the same as this. They're the same thing. So all a negative power means is flipped. What did we say? So one nice thing, if you don't like that last thing, really, we're not there yet. I just wanted to give you a complete picture. Negative numbers don't exist for us quite yet in this book, right? When we subtract, we're minusing positive numbers, right? But I just want to show you, just to make it complete. Okay. So one example I want to show you. All right, this is going to be silly. What's 4 times 3?
well.
12. What is 4 squared times 3 squared? What do you hope it is?
Didn't you write
If
that?
4 times 3 is 12, what's 4 squared times 3 squared?
Can't you write
12 4th power.
Oh, can you write it?
I don't have 4 12s. Every 4 and every 3 makes it 12, correct?
Oh, would you write it?
How many 4s do we have?
So it'd be 12.
How many 4s do I have?
2.
2. How many 3s do I have?
2.
How many 12s can I make?
2.
2.
144.
If you want to look at it in a different way, isn't this 4 times 4 and this is 3 times 3?
Yes.
If I use commutativity, can't I just
What if they have different powers?
say again?
Like, what if they have different powers?
Ah, okay. It's like I put you out there. I love it. We're getting there. You guys semi with me at the moment?
Semi.
This is just reorganizing the problem. It's not really, why would I add these powers? Are these like bases? No, so of course I'm not gonna add the powers. That's the only time I'm gonna add powers, if they're like bases, right? So this is different. These are numbers. I can reorganize them. I can commute them. I can do shit to them. So of course, real quick, what would 4 to the 5th times 3 to the 5th be?
12 to the 5th.
12 to the 5th. I can make 5 12s, because I have 4 3, 4 3, 4 3, 4 3, 4 3. I can make 5 12s. So if I had, what's wrong with this then? 4 to the 5th times 3 to the 4th. I don't have enough 3s to really fill out, but don't I have more than enough 4s? So don't I have 4 times 4 to the 4th? Don't I have 4 times 12 to the 4th? I just have an extra 4, do you guys see that? All we're doing right now is kind of playing with some shit. You guys with me? That's weird. But do you understand? Compared to this,
That's how we write the answer.
yep. Now, the actual answer would be kind of big. Yes, you agree? If I do 12 to the 4th and then I multiply by 4, it's huge. Okay. All right. So this is just playing around with some stuff. Which again, it's unfortunate in higher level mathematics, we don't let people play. It is unfortunate, because as humans, we all want to play. We just don't allow ourselves to do that. And in mathematics, you guys are like, what do you mean play? What the shit are you talking about, Chef? I mean, this is actually, now of course you guys are gonna like, oh, this poor guy. He thinks this is playing. This is what he does on like a Saturday night is he sits at home. That's an extra 4. No, but
He probably does.
this is just playing. This is what your students are gonna wanna do with this stuff. And you're gonna want to let them, and you're gonna wanna kind of meet them where they are and say, that's interesting what you did there. You don't wanna go, what is that? No, that's not anything what we're doing. No, you wanna go, that's interesting, yeah, you're right. We do have an extra 4, yeah, you could do that. Nothing wrong with that. Do you see what I'm saying? So you need to be at a point where you don't necessarily have to immediately understand what they're doing, but you have to be open to trying to meet them where they are. Whatever the hell they're doing, they wanna play with shit. If it's blocks, they wanna make a little thing. If it's numbers, they wanna just do stuff with them. They wanna draw them weird, they wanna do this kind of stuff. Yeah.
Can you do it with like a way higher power, like maybe like 4 to the 12
Sure.
times 4 to the third or something like that?
All right. Well, if it was 4 to the 12 times 4 to the times 3 to the
Yeah,
4th or something,
yeah, whatever.
how many 12s can I make? Because I only have 4 3s, right? So if how many extra 4s do I have then? How many extra 4s do I have? 8. Yeah. So then I got 4 to the 8th times 12 to the 4th. Right? Okay. And again, the idea I've talked about it for too long. It's not that huge important. Right? It does come up in a couple places, but it's not like the key thing. Okay? Just kind of reorganizing things, that's all this is. So it's really a question about if they're the same base, I can do something, correct? So then a natural question would be, what if they're not the same base? Can I still do something? And the answer is yes. In certain situations, right? You can definitely do something if they're the same power. So if I had 5 to the 7th times 6 to the 7th, are you guys cool now with telling me what the hell that is? I get 7 5s and 7 6s, so I can make 7 whats? 30s. So it'd be 30 to the 7th.
We wouldn't actually do 30 to the 7th power right on that number.
In fact, I don't even know if I think your calculator probably can handle that.
Yeah.
30 to the 7th, it'll be like,
358061.
okay. But these will quickly get out of range of your calculator. Yeah. Yeah. Okay. Enough of that. I didn't mean for that to be this huge thing. Okay.
Thank you, that really helped.
Good. That's one of my favorite phrases. Blah, 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 blah. Yeah, okay, now, I've already talked about a few things, which is kind of nice. I talked about some of the stuff earlier. But chapter 4, has anybody looked at the title of chapter 4 yet? It's called Mental Math, right? At least section 4.1.
I hate mental math.
Yeah. But don't overly freak out. I'm not gonna ask you to do the square root of 7,047 in your head. That's not the point. That's not what we're talking about. We're talking about stuff that we've already done. Sort of like, does somebody remember how to do 19 plus 44? What's kind of a strategy I can use? Yeah.
Oh, another way is like if it's mental math, you can kind of just guess a little bit, turn the 19 into a like 20.
Okay. Now how can I legally do that?
So plus 6 to the 44.
No. Oh, you could. You totally could. You're right. But if I make him into a 20, where'd that extra 1 come from?
44.
It must have come from. So if I add 1 here, I better take 1 away. So that's called compensation. Additive compensation. Compensation means your employer lost money and you gained money. Good. Somebody loses, somebody else gets. Yes? Compensation. So we have also multiplicative compensation, the same kind of way. So this is additive compensation. Everybody agree that whatever this is gonna be the exact same damn answer, right? It's just a lot easier to do. Now, this, like the video you told me, your parent would say, well, I would just do this. And it's like, well, good for you. But our students might not be at the point where they understand this algorithm yet, right? And this is okay. I could just show students, you go 9 and 4 is 13, but then you kind of take the 1 and you don't put it here, you float it up, and people think that's easy, but it's easy because you've already got a lot of background with numbers. So of course it's easy for you now, right? So parents completely don't understand why we just don't go here immediately. There's a ton of reasons we don't go here immediately. Holy shit. We want students to understand what's behind this. Why does this work? Again, thinkers, not workers, right? Okay, right shot. So then we get 63. Okay, I like it. Now this is called mental math, because in your head you go 1944, okay, 20 and 43. Now it's whole, you should be able to do it in your head a little better. Does that make sense? Yeah.
I was working with the kids like 4th grade and 5th grade last year. A lot of them, they make a mistake to carry that 1 to 10's place value, but they do it in their mind, that's fine. But if they go to like this way, like 70% they solve the wrong way.
Oh, if they try to
don't
do it this
carry-
way?
They forget to carry the one.
Oh, if they do it this way, yeah.
Yeah, they forget.
So the more you do mental evaluations like this, the more sense this will make later. And of course, I think I told you guys, if we use the pieces, the base pieces, you can actually physically see the one being carried. So we'll do that at some point, yeah. So this is called additive compensation. Can anybody come up with what a problem that would use multiplicative compensation might look like? The book calls it special factors sometimes, I think.
Are we using powers when you do the multiplication compensation?
No, not necessarily. Although that is multiplication, so good. So let me give us an example. Why is this multiplicative compensation? Can you give a number something the other number has to make it an easier problem? What's easier to multiply than 5, but that 5 is a factor of? What's the easiest number to multiply besides 1? 10. Could I steal something away from the 48 and give it to the 5?
Yeah.
To make it become a 10?
Yes.
So I could rewrite 48 as 24 times 2, right? 24 times 10.
Okay.
Yeah.
What happened? I'm sorry. Okay, wait, alright.
Breaking up the 48 into the 24.
Alright, so what does 5 need to become a 10 multiplicatively? It needs a 2. Does 48 have a factor of 2 in it? Does 48 have a factor of 2 in it? How do I rewrite 48? What times 2?
24.
24.
Okay.
So I'm writing the same problem again, right? It's like, go Jeff, look at you go. 24 times 2 is 48 days. So I'm not writing a different problem. It's the same damn problem, correct? But what am I allowed to do now? What's 2 times 5?
It's 10.
Yeah,
Oh, shoot.
and that's 240. So that is multiplicative compensation. Did I take a factor away from one and give it to the other one? You guys with me?
Yes.
What other number besides 5 do you think would this work for? Let me just give you 16 times 25. What would 25 need to become a really nice number?
Good, wait. Could you
If 10 is easy to multiply, what's the next number? 100.
Oh.
How many quarters make $1? 4. So if I could steal 4 away from this guy. So the real question is, will this always work? If that was a 17, do you want to steal a factor of 4 from 17? No. But when it does work, it's beautiful. Little tears. So 16 is 4 times 4. So then I can give that to the other dude. So that's freaking 400. If you look at 16 times 25, can anybody see it's 400 just by looking at it? No. But if I do this, all right, now I can see it's 400. We stop for a minute. Is everybody cool with that? These two are exactly the same problem. So you can tell like 5, 25, those kind of numbers are really good for compensation, multiplicative compensation. Yeah.
Another way I can see to do it, I might just be how you did it. You could square root both the 16 and the 25 to get it down to 4 and 5 times that by 20 to get that
Sure.
20 and then.
But we're nowhere near getting roots involved. Yeah.
Oh, okay.
Yeah. No, you're right. I'm sorry.
Okay.
Completely right. There's a ton of other ways to do this kind of stuff, but they're a little bit out of the purview of what we're talking about. Yeah. Where am I? Oh, okay. So compensation literally is just like real life compensation. Somebody loses something, somebody else gains it. Additively, multiplicatively. You guys all with me? So normally with additive compensation, you're trying to make whole numbers, right? Like not whole, but round numbers, because then they're easy to add. Right? Now, when I have subtraction, we talked about this before. Before I say that, there's something even more basic than this that we talked about. They're called compatible numbers. And I'm pretty sure I said compatible before. If you had to add 11 plus 6 plus 9 plus 14, I'd do 11 plus 9. Those numbers are compatible. Simpatico. Agreeable. So 20 plus 20. There. Yeah, we're gonna be smart, because addition, commutative property works. That's really all we're doing. Compatible numbers just means two numbers that together make a nice number. That's all that means, right? Okay. I like it. So you could argue that this problem involves the idea of compatible numbers, because 4 times 25 makes a nice number. Right? Okay. So compatible numbers are pretty straightforward. How about, that's a little weird, let me see. No, I'm not gonna do that, let's see. Yeah, okay. So we got compensation, we got compatible numbers. Something that's a little, well, we talked about this before. I'm pretty sure I called it this. When I'm doing subtraction, so if I wanted to do 82 minus 59. Can you imagine? You could totally do this, but isn't it a little gross?
Yeah.
It's a little gross. Does anyone remember we've done this before? What number is 59 close to that I wish I would have written up there? What's an easier subtraction problem? If I was subtracting 60, it would be so much freaking easier, right? So subtraction is how far apart two numbers are. So if I make one number go up 1 and the other number go up 1, is that distance different now?
No.
They're the same distance apart, so I'm gonna get the same answer. Subtraction doesn't give a shit what the numbers are, it just cares how far apart they are. You guys kind of with me?
83 minus
So if I make this go up by 1, I must make this go up by 1. That's gonna be the same answer, because they're the same distance apart. Does that make sense? So this equal additions thing is nifty. So you get, now of course, we did a problem like this on that group work thing. Some of your students are gonna say 30 something, yes? Do you see why? They're gonna focus too much on 80 minus 50, right? You guys kinda with me? Okay. When if you do this, you realize this is not far from 60, then it must be 20 something. That makes more sense. Okay. You could do this, it works the other way too. If I have 100 minus 27, I can do the other way. I can make this 99 minus 26. It's not quite as useful, but if you line it up, then it's easier, then you don't have to borrow shit. Do you see what I'm saying? No? This is the problem we did, and I get too many people to tell me the answer is 83. And that's not right, yes? But if you make it 99 minus 26, now can you see it's gonna be 73? Now it's more apparent that it's 73. I don't have a 10 and a 2, I have a 9 and a 2. Yeah?
So it doesn't matter how many you park though, as long as you do the same for both.
As long as I do the
So
same
you can do
number.
like 200
Yeah.
minus 127.
Yeah, 200. Well, I mean, even then I would just move it down by 1.
No, but I mean, just saying, like you can do 100 if you wanted to.
Say again?
It doesn't matter.
Oh, yeah, I mean, so you could say 200 minus 27 is the same thing as 100 minus 27. Is that what you're saying?
Yeah.
Yeah, totally, because then you moved them both by 100, correct? Totally, right? 10 minus 4 is the same thing as 20 minus 14. Yes? 10 minus 4 is 6, 20 minus 14 is 6, because they're the same distance apart. Cool. I like it. Okay. So that's what's called equal additions. Furniture moving class got a late start, it sounds like. Okay. How you guys doing? So we got compatible numbers, compensation, we got equal additions. Oh yeah, this gets a little bit freaky. Bless you. They are really going for it. So 371 plus 547. So if I had to do this,
Question, totally
sure,
kind
yeah.
of off topic, I guess. Why wouldn't we just use our calculator?
Because children
Oh,
don't have
okay.
calculators.
That's what they said on their
Alright.
phones.
So let's have a discussion, because this is a good point. Does anyone not see the utility in knowing how to utilize our number system, given that we have technology that can do this stuff for us? Is there any reason for the humans to know how the number system works?
Yeah.
Yes. So, I don't know if that was your point.
Well, I mean, like, not to be an idiot, like, obviously, but like, I'm just saying, like, it's a lot quicker, like, if we're
No, no.
adding, like, 3,000, and like, all these random numbers.
Sure. But when you're talking about when you're first learning numbers, this is what we're talking about, right? Now, you guys, if I said, it's 100 minus 27, I don't care what you're doing, right? But on a test, you're gonna have to show me these processes, right? Does it make sense?
Yeah.
In real life, I'm not gonna, so give me a second, 99, no, right? I'm gonna go, all right, yeah. You with me? Yeah, totally. But everything we're doing in here is about how to get young people that don't know shit yet to understand what the number system and how it acts, right? They don't know shit because we haven't shown it yet, that's why, right? Is that cool? So real quick side note, I have a reputation for being the by hand guy, the by hand math teacher. So I'll get somebody to take my stats course, for example, and I'll do something and they'll say, well, my last stats teacher let me just, put it into the calculator. I'm like, well, good for them. You don't have to anymore, too bad. And then I make a joke about their calculator is gonna pass the class, have a great life, and they're gonna be stuck taking it again. Do you think it's too harsh? Is that harsh?
No.
Oh, it's
No, I think it's funny.
I think it's funny. And it gets the point across, right? Yes, we have a lot of things that can do a lot of math for us. We need to understand
What's copy?
what math is, because somebody's gotta program that shit. Even that's not really the point, but at the very base level, we gotta know how to interpret what it tells us. We gotta know when there's an error. We gotta have a way to tell if it's off, right? So I do 8,000 minus 5,000 and you get 3. I should know, okay, that's not right. My batteries are dying, or something. Anyway, okay. So, left to right method. What do you think that would mean I would do?
You would start off by like adding the first two numbers.
Yeah, what's 300 plus 500? 800. What is 70 plus 40?
Oh my god.
70 plus 40. 110, right? And real quick, 60 plus 40 is 100, so 70 plus 40 is 10 extra, right? And then 1 plus 7. 8, thank you. So then what do I get? 918. You guys with me? So this, of course, is a great way to do something. It's before they learn about carrying the one and so forth. And now watch how I can set this up. This is a little early for this, but I don't care. If I set this up like this, 371 plus 547, and I go, okay, 300 plus 500 is 800, 70 plus 40 is 110, 1 plus 7 is 8. Can you guys see where the idea of carrying the one naturally happens? Can you see in here where carrying, if you did this, take a minute, please, just take a minute and just do this the way you know how to do it, and I mean by hand. Tell me where carrying the one happens. I like that. It's okay.
Yeah.
So where does a one carry to? What place does a one carry over to? The first place, right? So, I mean, the first one. So this is 8, this is 11, I gotta carry the 1. Look, didn't the 1 carry naturally? Do you see what I mean? So this is kind of like a step in the evolution towards the algorithm of carrying the 1. Do you see what I'm saying? And of course, adding whole numbers is relatively easy. So doing it this way is one step before showing them carry the 1, right? They can see why the 1 gets carried, because once they get up to 100, it's got to go to the next place. It rolls over. Okay. just remember, we don't have perfect
Miss Walker.
we don't have perfect memories. You are a little closer than third grade than I am, so I don't know, you might remember better than me, but I don't remember third grade.
I'm going back to her, she's gonna hear it.
Okay, gotcha. But just remember, our memories are not perfect. They very well could have told us all this stuff, and we just forgot or wasn't paying attention, whatever, right? Now, at the same token, there's a lot of stuff you might hear that you never were told. Sort of like, did I tell you about how to tell if a number is divisible by 9?
Yeah.
Okay, and I think some of you guys thought maybe you'd never heard that before, which is unfortunate, and I agree, it makes sense to me, because they are saying less and less about how to work with numbers in your head, and they're relying more and more on calculators, which is so sad. It is sad. Sorry, and it could just be me, I'm always open to that. Alright. There's a really simple one, multiplying by powers of 10, right? How do you handle that? Like, does anyone have a quick way to do 40,000 times 3 million? Not using a calculator?
12 zeros.
Yeah, 12, and then how many zeros? Sort of confused. Yes.
You can also just do the 3 times the 10, but 3 times 4, and then just count all the zeros and make that the exponent.
Yeah, sure, you can make it exponents, exactly. So what would this be? 10 to the 5th times 10 squared. Now you guys all know this, right? 10 to the, no, come on. How many 10s are here in a string? There's 5. Tack on 2 more. How many now? 7. Don't you add powers when the bases are the same? Real quick, just to really make sure you understand this. What is 3 to the 5th times 3 to the 3rd? Does anyone think it's 9 something? This is definitely, so if somebody writes this, right, just to make sure that is wrong. Why is that wrong?
It's like a complete
Because you don't have any 3.
Do you see, first off, do you see why they think this?
Yes.
Because of course, 3 times 3 is 9, Jeff, and then there's 8, shit, no, that's right. But what would I say to them? I would say, how the hell, I don't see 8 9s. I don't see any 9s. I see a bunch of 3s. How'd you get 8 9s? Right? This power means I'm not multiplying shit yet. How many 3s do I have to multiply eventually? 5. And then my boss comes in and slaps 3 more 3s. Ah, shit, screw you. I had 5 already, and now you gave me 3 more, so now I got 8 to do total, right? So it just added more work to me, damn it. So I'm not
You don't
multiplying.
completely ignore the whole number, right?
Say again?
Because I'm noticing that it seems like we're just ignoring the whole number.
Not we're ignoring it. We just aren't multiplying anything yet. 3 to the 5th literally means multiply 3 5 times, right? Multiply 5 3s. I haven't done that yet, correct? And then I got 3 more 3s to multiply on top of that, so of course I got 8 3s to multiply. I wouldn't make it 9 because I'm not multiplying shit yet. I'm just keeping track of how many multiplications I'm going to do. Does that make sense? So a lot of times if I do 7 to the 4th divided by 7 squared, somebody tells me it's 1 squared over 1. Same reasoning, right? They would do 7 divided by 7. But no, that doesn't make any sense. I got 4 7s and 2 7s. So how many 7s would be left? 2, yeah. I'm not dividing the 7s. I'm just
Then could we
losing.
write also 14 and that'll be right?
Say again?
Could we write?
No, careful. What 7 squared mean?
40.
Oh, okay.
7 times 7.
Yeah, so
Yeah.
we could write 49 though.
49.
That'll be-
Yeah, so you could do this, and then you could put 49. Yeah, but in general, I don't need you to necessarily, because if you get 3 to the 11th, I don't want to.
Yeah,
Okay. Yes?
So what was the whole point of the multiplying by powers of 10?
Oh, just, we know how to do it. I just want to say it really quickly. When you multiply by 10, you add another 0, right? 10 times 7 is 70. So if I multiply 100, I add 2 zeros. So if I multiply by 1,000,000, I add 6 zeros, right? So I had 4 zeros, I had 6 more zeros, I end up with 10 zeros. You guys with me? Okay, that was my only point. It wasn't anything deep. Nah. Yeah, alright, let me show you this. This is kind of cool. The book has a little section they call special factors, which I find to be kind of a little funny, but this is kind of interesting. You guys might be like, finally, something interesting. How would you feel about if you had to do that?
8.
Now, that is really close to what number that would be kick-ass? 100. Do you guys see, one way to interpret this, especially if it turned around, would be 99 12s, correct?
Yeah.
Isn't that 1 12 less than 100 12s? 99 12s. 99 chairs would be 1 chair less than 100 chairs. You guys with me? Is that a true statement what I just said? Don't look at that, look at me. Look at me now. 99 chairs would be 1 chair less than 100 chairs, correct?
Yeah.
Okay. So watch this. Can't I write 99 as 100 minus 1? What property could I use then?
Distributive.
So that is 112s minus 112. What's 12 times 100? 1200 minus 12 is? And again, if you want to, you can make it 1199 minus 11, right? Equal additions, right?
1188.
Huh? Yeah, 1188. That's a lot easier than show this to the person that did that weird ass TikTok and show me whatever it was, right? Look the way we do it. Well, you know, in the meantime, the kid's got the answer right.
Remember the kid?
We get that again, like.
They should see the video because the kid did some weird stuff.
I know.
Is it the
I'm
Chinese?
not even sure I want to show it.
Method,
Yes.
That one, the dot.
Oh no! The Chinese thing is nifty,
Yeah,
but
it's
it's
nifty.
not
It's
extendable.
slow.
It's not. Yeah, it's not really
I don't know
useful
if
for
that's-
other things. I don't
It's
know
like
if I want to show.
It's a weird
It's
cross.
Not very
method.
elucidative, but I got a kick out of it. Anyway,
I thought it was funny.
this you could do in your head if you really, really had to. You could. You could do this in your head. This, not the easiest thing in the world to do in your head. You agree? Okay. Maybe? Yes?
On your thing, how did you get from, was that 1200 minus 12, and then you wrote 1199 minus 11?
I took them both down by 1. So the distance
you were
between them
just
stayed the
showing-
same.
Okay,
Yeah.
but, okay.
Because when I wrote 1200 by 12, I felt some trepidation about what that was. So I reminded everybody you could do that.
Okay.
So what about that makes it different than other methods? Like,
Oh, this is the first time we use distribution, haven't, isn't it? Isn't it the first time we use distribution to help us? Another way to use distribution. What about to do 21 times 19? Watch this, you ready?
Oh,
20 plus 1 times 20 minus 1.